Assalamualaikum warahmatullahi wabarakatuh to my panel Dr. Nur Azlina and Dr. Abdul Manaf. I am Muhammad Badrul Amin bin Salleh and I'm under supervision of Prof. Madia Dr. Nur Hafiz bin Muhammad Nur. And so here I am today to present my FYP proposal and the title is NiTi Powder Analysis in Additive Manufacturing. Okay, let's begin with the summary of this project. Simulating the additive manufacturing process of NiTi is very complex due to the microstructure change and the electropic transformation occurring during its thermomechanical processing. Validation of the thermal and mechanical model was performed by compare the simulation result and with measurement available in the literature, which show good agreement. Next is to conduct simulation analysis of additive manufacturing of NiTi powder by varying process parameter and find the best process parameter with minimum 1 meter stress uh, and minimum temperature. And for the last is using ADDITIVE software to conduct the simulation. Okay, that is introduction of this project. In additive manufacturing industry, NiTi powder is one of the materials that widely used because of its superior functional properties, including as shape memory and super elasticity. NiTi is the most often used SMA. To fabricating NiTi product, there are several methods that can be used. Selective laser method are the most widely utilized additive manufacturing technique for creating NiTi product. Processing parameters are important during selective laser method. The optimal parameters are required to produce the best product, which is to ensure the product is not only totally dense but also has a low impurity content. These two requirements are critical because they influence mechanical performance, specifically height strength, as well as the success of possible application, such as medical application. Simulation of additive manufacturing will find the best processing parameter, such as power, scanning speed, and thickness layer. It is to produce the product with the minimum 1 meter stress and minimum of maximum temperature. All the simulation can be done by using ADDITIVE software. Okay, next it is a literature review of this project. Firstly, is a NiTi powder. In recent years, shape memory alloy have entered a wide range of engineering applications in fields such as aerospace and medical device. NiTi is the most used SMA due to its excellent functional features, including shape memory and super elasticity effect. These properties are based on solid-solid phase transformation between martensite and austenite. Besides these two characteristics, low stiffness, biocompatibility, damping characteristic, and corrosion behavior of NiTi make this alloy an attractive candidate for biomedical applications such as bone plate, bone screw, and stent. Okay, next is additive manufacturing, selective laser melting. Additive manufacturing is a specific 3D printing process. By depositing material according to the CAD data, this technique will create component layer by layer. The common additive manufacturing technique for NiTi are selective laser matting. Selective laser matting have a processing parameter that need to set before the process running, such as scanning speed, laser power, and the layer thickness. Next is selective laser matting processing parameter effect to NiTi powder. During the selective laser matting process, there were a few parameters that can be changed. The processing parameter that give a huge impact on the mechanical properties are the power, scanning speed, and the layer thickness. Processing parameter will affect the mechanical properties of the product due to the different heat distribution to the product. Okay, for the next is LS-DYNA. LS-DYNA is a simulation package with advanced capability. LS-DYNA has a wide range of possible applications and may be adapted to a variety of sectors. In nonlinear analysis, it is known as an exceptional finite element numerical simulation software with explicit and implicit analytical function. Complex nonlinear dynamic issues such as nonlinear material, massive deformation, crack propagation, dynamic contact analysis and failure analysis and transient thermocouple problem can be evaluated by using LS-DYNA integration approach. For the problem statement, the mechanical properties of NiTi product that produced under SLM process are nonlinear. So from this, processing parameters such as power, scanning speed, and layer thickness are really important to produce the best NiTi product with the minimum 1 meter stress and minimum of maximum temperature. After that, SLM process, which is a selective laser melting process of NiTi, is very complex due to the microstructural change and allotropic transformation occurring during its thermomechanical processing. The result from the metallurgical model explicitly affect the mechanical properties in the flow stress model. All the problem can be overcome with build a numerical model of SLM process by using LS-DYNA. From the numerical model, different processing parameter can be applied to find the best one meter stress and minimum of maximum temperature. For the objective of this project, the firstly is to analyze the sensitivity of the powder particle by numerical model to the process parameter and modeling data in additive manufacturing. Secondly is to conduct a simulation analysis of additive manufacturing of NiTi powder by varying process parameters such as size, power, layer thickness, and scanning speed. And for the last is to determine the best process parameter with minimum 1 meter stress and minimum of maximum temperature by using LS-DYNA software. Okay, next is scope and limitation of the project. Scope of this project is to simulate the additive manufacturing process of NiTi powder. In this research, selective laser melting technique are chosen as a process that will be simulated with using NiTi powder. LS-DYNA will be used to run the simulation of additive manufacturing. During the simulation, various of process parameter will be used to determine the minimum 1 meter stress and minimum of maximum temperature. All the NiTi powder mechanical and thermal properties will be collected by doing research. Okay, for the methodology of this project, this is the flowchart for this project. It will start with the literature review and then model development and derivation. For the model development and derivation, selective laser mapping will be chosen as a simulation that will running using LS-DYNA. During the simulation, various of process parameter will be applied, which is power, layer thickness, and scanning speed. After that, by using LS-DYNA, we can get the properties of the product that we want to analysis, which is 1 meter stress and minimum of maximum temperature. The data of the product will be recorded as a result of the simulation. The result will be compared with the experimental result. Okay, that's all for the methodology, and then it will be writing the thesis report and submission. Okay, for the last is expected result. The simulation of selective laser melting with various processing parameters will done with a high accuracy. After that, mechanical properties will collect for each of the parameter chain. This is the table result for power as a variable. Okay, this is a result table for scanning speed and layer thickness as a variable for this experiment. Okay, that is the end of the presentation. Thank you to Dr. Nur Azlina and Dr. Abdul Manaf, and thank you to my supervisor, Prof. Madia, Dr. Nur Hafiz, and that's all from me. Thank you.